Okay, and so over the last couple of days, we have talked about that arithmetic sequences behave like linear functions, and that geometric sequences behave like exponential functions. But we're going to look a little closer, bless you, at those different types of ways to represent both of those, or all of those different types of sequences or functions. Bless you. And then we are going to really, after today's lesson, really start focusing on exponential functions, kind of move away from the sequences. So anyway, the arithmetic sequences, there is a way to write it using an initial value, and that's basically the same thing as slope-intercept form that you learned in Algebra 1. And then we didn't use that one very much, but we did use this one a ton, which is very much like point-slope form, which we've used a lot. We used it on at least 2 tests to write secant lines, so those are super similar. All right, and then geometric sequence, there's one using an initial value. Exponential function also can be written using an initial value. The difference is, bless you, is that just the notation. So R is the common ratio of a geometric sequence on an exponential function is called the base, and it's represented by B. Sometimes it's represented by R also. And then you can also have any term in the sequence and write the geometric sequence, and same thing with a exponential function. You can have any value and you can still write the equation. All right, and then we also need to look at the similarities and differences between linear functions and exponential functions. And so for linear functions, over equal length input value intervals, so that should be ingrained in your brain. We're going to write it several times today. But for linear functions, the output values change at a constant rate. What is that constant rate called on the function? Which one of these is it? It's m, the slope. So they change at a constant rate. That constant rate is the slope. All right, exponential, brand new equation for us this year. Still over equal length input value intervals, the output values change proportionally. And that value that is changing by proportionally is called the base of the function. And we'll talk more about that throughout the next week or so. All right, and then m, the change in y in a linear function, is based on addition. So you're adding something each time, or adding a negative or subtracting. For the change in b, or the change b in y on exponential, is based on multiplication. So you're multiplying by that base every time. And one thing that is similar to them is that if you have 2 points, you can write the equation of a linear function or an exponential function. And we've already done that with arithmetic and geometric sequences. It's a very similar process. Okay, that's a lot of words. All right, let's do some examples. So on the back, we have these tables of values, and we are going to determine if the function could be linear, exponential, or neither. And so we do have to have equal length input value intervals, and if we look at A, we have that. They each have a length of 3, and they're consecutive, so nothing is skipped. Just go by 3 each time on the inputs, so that's good. So now we look at the outputs. How are the outputs changing on A? They're going down by 2. You're subtracting 2 each time on these outputs. All right, so what does that mean this function is going to be? Linear, exponential, or neither? Linear, yes. All right, now we have to give a reason for our answer. This is where your hand might start cramping up. All right, so we do need to say over equal length input value intervals. And we could say the first differences are constant. That is right. I'm going to just go ahead and word it this way because I feel like multiple choice, that's how it's going to be worded. So we're going to say the output values change at a constant rate. All right, so let's look at B. Input values are good. They each are have an interval of 1 length. But let's look at the output values. Are the output values changing by a constant rate? No, you're not. Adding or subtracting something, Sham. What about multiplying? No. So if that is the case, this is a situation where it's going to be neither. So when it's neither, we can skip the whole equal length input value intervals on this one, but we would just say that the output values don't change at a constant rate. Or change proportionally. That's what you say for exponential. You say that the output values change proportionally. They don't here. So this is a certain type of function. It's just not linear or quadratic or exponential. All right, let's look at the next one. Input values are good. What's happening on these output values? You're multiplying by 2. Very good. All right, so when you're multiplying the output values by the same thing, then that is going to be exponential. All right, we do need to talk about the input value intervals. All right, and then we're just going to word it like we have it on the front. The output values change proportional. I've been spelling that wrong. Let's spell it right. I think it might be okay to spell it either way. All right, so you guys try D on your own, please. right, any questions? Okay, the last two examples are application problems for sequences. They could very easily, instead of sequences, say exponential function, or here instead of arithmetic sequence, it could say linear function. You would do the exact same thing. So on example 2, this is kind of a silly example. A wild rumor is spreading about Mr. Passwater, or that Mr. Passwater won third place in the World's Strongest Man contest. He might have started it himself. The number of people that have heard the rumor can be modeled by a geometric sequence. That's important. Someone in my last class did a whole problem with the wrong type of sequence and had to start over. So just make sure you find those words in the problem. And then where 43 people had heard the rumor on day 3. So I'm going to go ahead and say, since it's geometric, G of 3, or G sub 3 is 43. And 140 people have heard the rumor on day 6. So G sub 6 is 140. According to the model, how many people to the nearest whole number have heard the rumor by day 10? All right, so we are going to use this guy. And it is important, just to make it easier for you, which one of these is a sub n and which one is a sub k. Do you guys remember which one we should choose for a sub n? The bigger k. So yeah, 140 in this case. Good. Okay. Bless you. Got all kinds of allergies going on today. All right, so I want you guys to use your calculator today. I know I've been like, do as much as you can without a calculator. Today you can use a calculator, anything you want to. And one thing I want you to do with a calculator is do not round until the very last step. So I'll show you what I mean. So when we're solving this, the first thing we would do is go ahead and divide 140 by 43. And we get this ugly decimal. And on our paper, we can round it. We don't have to write out all those digits. But in a second, when we find the cube root, we're not going to find the cube root of the rounded number. We're going to find the cube root of the whole number. Do you guys know how to do cube root in the calculator? Yeah, math 4. Now, there is one you have to do on your assignment that you have to take, like the 56th root or something like that. Do you guys know how to do the 56th root? You would use 5, and you would make 56 your little index. Okay, good. Okay, now there's 2 options here. You can do second negative and it'll bring up the last thing you typed, or you can just go up and choose it, which for some reason I like to do better, because sometimes it isn't the last thing, it might be a couple of ones up. Either way, we want the whole number, the entire number, not the whole number, the entire number. All right, and so again, we can write that R is 1.482 something something something. And that's what we can use in our formula, but whenever we go to find the final answer, we're going to use the whole number, the entire decimal. All right, so at this point, it does not matter if we choose the 343 or if we choose the 6140. Your calculator's doing all the work. It doesn't matter which one. All right, so that's our G sub n. So what do we need to put in? Oh, sorry. What do we need to put in to answer the question? 10. Okay. So we're going to do 140 then that decimal we just got raised to the 4th. That's it. All right, and then we want to round to the nearest to the nearest whole number, which is going to be 676 people heard this rumor. Now, this will be on the multiple choice part. I don't think that your choices are going to be so close together that you would miss this question, but I don't know. So it's a really good habit to only round once. I'll say that lots and lots. If you take calculus, I'll say it even more in calculus, but only round once, the very last step. Okay, you guys good? Okay, we're going to do one more. On example 3, a large theater has rows of seats where the number of seats in each row can be modeled by an arithmetic sequence. We do know that the 5th row has 31 seats and the 11th row has 49 seats. And so we want to determine how many seats there are in the 25th row. Thank you. All right, so we are going to use this arithmetic sequence formula that I hope you know. If not, hopefully you will soon, because we're going to have a quiz this week. I can't remember if it's Thursday or Friday. I think it's Friday. Okay, so we need to find D. And finding the common difference is easier, in my opinion, than finding the common ratio, because it's something that we've done tons of times. We're finding the slope or finding the average rate of change. I feel like you guys should be able to do that in your sleep. So we're just subtracting 49 and 31 in the numerator and 11 and 5 in the denominator. And this one works out kind of nice because we just get a whole number common difference. So this one you might be able to do without a calculator, but you can still use it. It's fine. All right, so then I'm going to write my formula. It doesn't matter which one, which point we use. I'm just going to go ahead and use the second one. All right, and then to answer the question, we're going to put 31 in for n. Oh, wait, hold on. I don't know. I have no idea where I got 31. Oh, I do. I looked here. Anyway, we're going to put 25 in for n. And then you can just let your calculator do all the work. And that 25th row should have 91 seats. All right, so what questions do you guys have? It's not too bad. Just a little bit of writing, but it's doable.